Alright, hello everybody. I chose section 1.4 question 102, in which we were to determine whether the given equation is true for all values of the variables, and if not, we were to give a counter example. For our first question, we had 5 plus a over 5 is equal to 1 plus a over 5. And to find if these are equal, we first have to resolve our whole number plus a fraction. And to do that, we would need to find the least common multiple and add the whole number, which the least common multiple in this case would be 5. So we multiply this whole number by 5, which gives us 5 over 5 plus a over 5. And we can now add the fraction because we have a common denominator, which gives us 5 plus a over 5, which is in fact equal to the original equation. So no matter what values you plug in for a, these two sides will be true. Now for our next question, we are given x plus 1 over y plus 1 is equal to x over y. Now this one seems pretty self-evident, but just to prove the counterexample, what we'll do is we will give x a value of 2 and y a value of 3, and we'll go ahead and plug those into the equation to show that these are not true for all values. And so for the value of x here, gives us 2 plus 1 over, for the value of y, gives us 3 plus 1 is equal to the value of x, which is 2, and the value of y, which is 3. And adding our fraction on the other side together, we have, that gives us 3 over 4 equal to 2 over 3, which is not true. Now for our next question, we are given x over x plus y is equal to 1 over 1 plus y. Now for this same equation, we can take a similar variable numbers that we had before to prove a counterexample that it is not true as well. We can plug in our values of x is equal to 2 and y equal to 3 and go ahead and plug them into the original equation, which would give us the value of x, which is 2, over the value of x, which is 2, plus the value of y, which is 3, equal to 1 over 1 plus the value of y, which is 3. And this gives us 2 over 5 equal to 1 over 4, which is not true. And really the only value which would make this true would be if x was equal to 1. Now for our next one, we're given 2 times a over b equal to 2 times a over 2 times b. And this one again is proven to be not true, and we'll go ahead and provide the examples. To solve this one, to multiply by the fraction, you will multiply the whole number to the fraction, which would be 2 over 1 times a over b, which gives you 2a over b equal to 2a over 2b. And the 2's on this side can in fact cancel out, which would just give you a over b. So for your final equation, you have 2a over b equal to a over b, which is of course not true, and we can go ahead and plug in a value of that to show that if we were to set, we'll go ahead and stick with the same variable numbers we had before. We gave a equal to 2 and b equal to 3. We plug in our variable numbers, and you would have 2 times 2 over the value of b, which is 3, which that gives us 4 over 3 equal to a over b, which would be 2 over 3, which is of course not true. And for our next equation, we have negative a over b equal to negative a over b. And these ones are in fact true for all values of the variables, because of the fact that any negative divided by a positive is going to be a negative, which in this case, if you took the negative of a positive by a positive, you have a negative. And if you divide a negative by a positive, your final result is a negative. And just for giggles, we can go in and plug in a negative number, because one might think that that would actually resolve that to be a possible counterexample, but it's not. And we'll go ahead and use similar values to what we had before, but we'll set a equal to negative 2, b equal to 3. And we can go ahead and plug in our variables. Here we would have negative 2 for the value of a over 3 equal to negative 2 over 3. And in both of these cases, this resolves to the negative of a negative is a positive, so you end up with 2 over 3 is equal to 2 divided by 3. Negative 2 divided by 3 is of course a negative fraction, and the negative of that negative fraction would end up being 2 divided by 3. So this is in fact a true equation for all variable values, other than those that would make b 0, because you can't have a denominator as 0. And for our last question, we have 1 plus x squared over x equal to 1 over x plus 1 plus x. Now this one might seem kind of tricky, but it is in fact a true equation for all values of x. And this can be broken down and shown that because you would have 1 divided by x plus x divided by x plus x squared divided by x equal to 1 over x plus 1 plus x. And x divided by x is always going to, any number divided by itself is going to ultimately end up being equal to 1. So this is going to give us 1 over x plus 1. And with the x squared divided by x, that's when we deal with the quotient of powers property. When you divide powers with the same base, you subtract the powers. And so what you have is, this is ultimately x to the 1. So 2 minus x to the 1 gives you x over 1, which in fact just becomes x. And so there you have 1 over x plus 1 plus x is equal to the other side of our equation, which is 1 over x plus 1 plus x. and they're balanced on both sides, so any value of x that you plug in will equal and become a true equation for both sides. Thank you.